Hello everyone, my name is Angel Rivera. I'm a developer advocate at CircleCI, and today I'm really excited to talk to you about a new feature that we've released here at CircleCI. The new feature's name is ARM Compute, and what it essentially does is enables developers to build and deploy their applications to ARM infrastructures using CircleCI and AWS's Graviton2 platforms. Now with CircleCI, you can build, test, and deploy software compiled for ARM architectures without ever having to manage your own ARM compute nodes or infrastructures for your CI/CD pipelines. This enables developers to focus on what really matters, which is their code, as well as enables developers to now support other compute infrastructures such as ARM with their applications and services. As we all know, ARM processors are gaining popularity across cloud computing and many devices since they often deliver significant performance improvements without sacrificing power or cost efficiency. In this video, I'm going to demonstrate how you can easily implement ARM compute nodes within your CI/CD pipeline configurations so that you can build, test, and deploy your applications to any infrastructure that requires ARM. I will also be demonstrating how you can basically deploy an application from an ARM-enabled pipeline process and deploy that application directly to an AWS Elastic Container Service cluster that is solely supported by Amazon's Graviton2 EC2 compute nodes. So you get that end-to-end ARM experience from your pipeline all the way through to the deployment. And that's really cool for developers to be able to understand how their applications are performing on ARM resources, as well as hosting those applications on, let's say, production level ECS clusters. So let's jump into the demonstration. Okay, so let's just jump into the CircleCI dashboard. What I'm showing you here is an example project that I'm going to use for my demonstration. And what essentially is going to do is show how you can easily implement the new ARM compute node executors within your CI/CD pipelines. And it'll also have a few steps in the pipeline configuration that will leverage Terraform to provision and deploy an application that is compiled for ARM, as well as, again, configure and create the AWS Graviton EC2 node instances that'll be supplying the hosting capabilities for our ECS cluster. So let's jump into the project that has the code. Right here I have a configuration.yaml file for our project. As you can see, I've kind of collapsed most of the jobs that are running in this pipeline, and I'm doing this just to focus in on the bits, specifically, and we'll expand all the things to show you the complete pipeline. But the first thing I want to tackle here is this run test job. It's essentially one of the first things that we do, when we're running our CI/CD pipelines. So as you can see, I have a job called run test. And what I'm doing here is enabling an executor of the type machine. This could be Docker, macOS, or Windows. Obviously, it's a machine type here. The reason why it's machine, our new feature, ARM Compute, is only available right now on a machine type executor. So in the future, we'll be adding the capability for ARM to Docker and the rest of the executors. But at this point in time in the preview, we're just going to focus in on the machine executor. So first thing you want to do is, and this is very similar, right? If you're experienced with CircleCI, this should be or feel very similar, or be viewed as very similar to people who are experienced. The first thing is you want to set up a machine key. Obviously, you want to define what image, right, to use in this machine executor. Here we're going to use Ubuntu 20.04 as our image, and this is where you actually will implement the ARM or define the ARM capabilities, right? So we have this resource class key, and obviously we want to use an ARM architecture or platform. So what you would do is just basically, assign it an arm dot medium, which is the size of the compute node. Right now, the ARM support comes in two flavors, which is the dot medium or the dot large. We'll be adding more resource classes, obviously, and instance sizes for this resource class, for the ARM node particularly, at a future date. But for the preview, all you have available to you now is the medium and the large, which should be fine for most of the workloads that we're going to run on this. The second thing here is I wanted to jump on or tackle is the node orb. For those of you that are not familiar with orbs, CircleCI basically has a component or a feature that enables you to package functionality right within your CI that are executed on your CI/CD pipelines, and actually enable you to reuse them. So think of it as more of a reusable class of functionality within your CI/CD pipelines. Orbs are primarily maintained in our CircleCI Orbs registry, which you can check out online. But essentially what it is almost like a package management repository, similar to like NPM package manager or Docker Hub, right, where you store repositories of different images, right, that do different things. So with orbs, they're really cool because if you have a functionality that's repeated throughout your pipelines, you can actually encapsulate that functionality and then offer it up as again an orb and then the specific functionality. In this case, what I'm doing here, and this is how I instantiate it in my code. Real quickly, right? It's just CircleCI is the maintainer of this orb, and then the version of the orb, which changes, right, as we make improvements or modify the orb's capabilities. The node label here just signifies an alias to use within my CI/CD pipelines. So if we jump down into the run test job, obviously here, right, leveraging the install packages command from the node orb, and the two parameters or the two functions that I'm leveraging are the override CI command, because I want to tell it to basically run npm install on my code, and then we have a caching mechanism, and this basically kind of encapsulates all of CircleCI's cache features and capabilities. And what I'm doing here is just specifying the folder that I want to cache within my orb, my node orb instantiation. Let's jump down to the run command, right? Essentially, it's no different, right? Once you establish that you're going to use this executor, all the commands should seem very similar, right? Because this is ARM is essentially Linux, so the only difference is the underlying hardware and architecture that you're running your code on. Obviously, if you're going to run things on ARM, you have to compile your applications for ARM, which is why we're introducing this resource class to enable developers to be able to easily do that without having to understand the architecture of the platform. We just kind of want to give you the easiest possible solution to improve that developer experience. So once we've run our code, basically what we're doing here is going to run a few tests on our code, which is very typical. And again, right, these are normal regular commands that we use to store our unit test results and pin them to the actual build. Moving on to another job, which is going to be, once we run our tests in our application, we want to create an artifact to deploy, a deployment artifact. In this case, I want to create a Docker image based off of this application. As I mentioned earlier, you have to compile things for the architecture that you're targeting to deploy to. In this case, again, we're going to choose ARM. So you would declare a resource class of ARM. We're going to use the medium capacity because it's definitely suitable for what we're doing. And if you jump down to the run command, right, which is where we're actually doing things, you can see, right, there's no difference in, again, executing the client for the Docker build. We're just creating a few environment variables so that we can create a unique name that corresponds to the actual pipeline build and workflow build that we're doing. So again, really simple. If you built Docker images and deployed them to like a Docker repository, I'm using Docker Hub, which is why you see a couple of login credentials there, or at least login commands, and then the push command will push it to Docker Hub. Once we have our Docker image built, now we can actually deploy this new image to an ECS cluster that we will create using Terraform. This is really cool because what we're doing now is, since Amazon has ARM support as well, through their AWS Graviton2 EC2 compute nodes, we're able to leverage those ARM nodes, right, to build a ECS cluster based off of those ARM compute nodes. Again, if you're going through the configuration, we're going to define a resource class again to use the ARM resource class at a medium, and then we're going to check out some code. Right here is this run command here basically enables us to leverage the Terraform cloud, so they can manage our Terraform state, which is kind of like the source of truth for any kind of infrastructures that we deploy using Terraform. The next thing I want to talk about here real quick is the install Terraform step in my job. This is a good example of how to leverage what we call CircleCI parameter variables. Up here, I've created a commands section in my pipeline, and what this commands section does is enable you to create reusable instances of commands, or things that you're going to execute in the form of commands, right? So again, I've defined a new install Terraform key here. I give it a description, right? And as you can read here, it's basically enables you to specify which version and compute architecture you want to download for Terraform. So the Terraform CLI has, support for Linux 64-bit. It has support for Mac OS, Windows, and also ARM 64. So this just makes it a little bit easier to execute this install Terraform command a lot easier, right? And makes our code more readable. I'll just jump through this real quick. Obviously, you set up a parameters key, and then these are the variables, right, in the form of parameters that we're going to define and then use later on. All I'm really going to do here is two parameters, a version and an architecture parameter. And the defaults for these, right, the version is 13.5. And then the architecture is going to default to ARM 64. If you have these defaults set, then you don't, and you're targeting like ARM 64, you don't really have to define them in your pipeline, as I've done later in this example. And finally, right, since it's a command, you have to run something. So we created a run block here, and basically that the run block is called install Terraform client, right? And all that does is those parameters, right, are now used in your wget URL command. So we already know that the structure of the URL for downloading Terraform CLI from their releases site. And what I've done here, right, is added the parameter, the flexibility here to define which versions of that CLI you want to. So obviously you have to build out a wget command or a URL, and this is all this parameter is doing is essentially, replacing the bits that need to be dynamic in the URL, which is the parameter version. And then obviously, right, we're gonna use it again because that's the way the URL is structured. And finally, it tells it the architecture, right? So combining all of this in a string will give you a legit, resource to download from the HashiCorp site, which is that client. Finally, where you're going to use those variables again to unzip because they are part of the file. And then eventually we get that binary that's ARM64 capable, and we're going to move it over to a user local bin directory so that binary is available to every user on the executor, which is the ARM executor. So now that we kind of covered the install Terraform definition, right, the pipeline variable definition, I'm going to show you how you can leverage it in the job, which is here. again, right, all of that work just gives us the ability to streamline our functionality within our pipelines. And by the way, you can encapsulate that same parameter functionality into an orb if you wanted to, but that's for a later video. So we have this install Terraform command. We're leveraging that, right, to download and install the appropriate binary. Again, in this case, we're using an ARM64 binary since we're going to deploy ARM64 infrastructures. So finally, we have this last run command in our job, and essentially, again, I'm just building out a couple of environment variables to tell the system or Terraform which Docker image to deploy. As you can see here in the Terraform apply command, which is actually what executes your Terraform code, right, in provision software. I've created a couple of Terraform variables and associated them with the variables I created above, so that, you know, again, the Terraform has some values and the exact Docker image that I want to deploy, which is a part of this pipeline. Finally, this auto approve flag enables Terraform to just do things without any interactivity from a human. This is, if you run this apply command without this auto approve flag, it will prompt you, and that's not what we want in our automation, right? We just want to, we already know like it's going to work, or we hope that it's going to work, and we want it to just kick off and go. So that's great, right? Like, let's take a moment here and take a look at our project in Terraform, or in CircleCI's dashboard. So here's some previous failed jobs, right, that I've done. But let's go ahead and actually deploy a change. So I have an application here, and let me go ahead and pull up the application. What I'm going to do is, this is a simple static web page, but the cool thing, what we're going to do is change something so that we can then, deploy this to an Amazon Elastic Container Service that's, again, built on Amazon Graviton2 EC2 instances, right? So that gives us that ability to host an ECS cluster using ARM only Graviton instances. It's pretty exciting and really, really cool. So let's go ahead and, I don't know, let's change some text here. Let's say, welcome to CircleCI 101 using, welcome to CI/CD 101 using CircleCI on AWS ECS, right? I think that's a cool message. So let's go ahead and save that. And now we're going to go ahead and jump over to our terminal, and we're going to do a clear. Let's go ahead and git status. Cool. So we have this application that we want to deploy. Let's just all right, let's do the git status again, all right, cool. So let's do a git commit, and then we're gonna say, was it app.js? And then we're gonna give it a message, updated text, right? All right, cool. So now we can deploy this by basically, using the normal git push. And once that occurs, we can jump over to our dashboard, and hopefully our CircleCI job will be kicked off, or pipeline will be kicked off, because CircleCI detected the code change with our push. Now it's going to run my pipeline. If we dig deep into it, we can see that we have 3 jobs running concurrently. Now, these jobs are basically essential for our pipeline, right, to execute and perform all the things that we've defined in the pipeline configuration file. Now, these are all running on ARM instances, right, or ARM executors. As you can see here, the executor is Linux, and it's an ARM based compute node. So if we go back to our main pipeline workflow, you can see that things are happening concurrently. I also created, if we jump into the deploy AWS infrastructure. Basically, you can see, right, the install Terraform client that we talked about earlier. And Terraform is kicked off, right? It's going to create our AWS ECS cluster based on AWS Graviton2 EC2 instances. Our cluster has been created, and if we go back one, we can now see that our test failed. And the reason our test failed is because I have some validations that I do, right? So obviously we're testing for some static text. Since I did that, our AWS ECS text, we should probably change that back. So let's go ahead and make some changes to our code again to revert what we've done. And once we do that, I think we can save it, and hopefully we'll have a successful push or a successful build. So if we go back to our main, we had a failing build, right? So I'm going to cancel this because I have an approval step. And what I'm going to do here is cancel that build. And then we're going to go ahead and change our text back, which we did. So let's go ahead and commit that code. First, check the status. Cool. So we're going to do that again. And then we're just going to git push our change, right? So that our test will pass this time. And once we do that, we're essentially going to be kicking off a new build since our code changed again. You can see that our pipelines have kicked off again. Now, while we're waiting, let's jump into basically the project again. So now that we changed our application, hopefully our test will pass this time. What I want to do is show you, right, that obviously it's built the AWS cluster, and we can see that here in the cluster itself, right? So here's our ECS cluster based off of the EC2 instances. We have 2 container instances in our cluster. So if we dig into this, basically what we can do is see our EC2 instances. And again, right, like these are created with Terraform. And by the way, we also have auto scaling in these instances, right? So since we have the auto scaling, it's a really cool feature so that, you know, if you start deploying new nodes or new compute nodes, or if something goes wrong, we've programmed our Terraform to create CloudWatch monitoring, which also monitors for down nodes or nodes that are unhealthy, and it will automatically replace them. This has also created a elastic load balancer or an elastic application load balancer. So again, you know, let's go ahead and look at one of those EC2 clusters. As you can see, right, we have a TG4 medium, which is again a Graviton2 EC2 compute node. So we've built a cluster based off of Amazon's EC2 compute nodes, as well as our pipelines, you know, building the artifacts and the application and deployment artifacts, and then also deploying them using Terraform. So let's go back to our pipeline. Obviously, our test has passed this time, and we've deployed the infrastructure or the application to a new AWS EC2 cluster based off of Graviton compute nodes. So let's check and see if our application is actually running. There's the host name for our load balancer, and we're gonna paste that, and there you go. We have a fully functioning website based off of or hosted by an Amazon ECS cluster based on Graviton2 ARM compute nodes. So that's all well and good, right? We've created and deployed our application, and if we look at what's happening, you know, things run concurrently. They ran really, really quickly. But now I've introduced an approval step, right, in our workflow, which essentially, I mean, gives you the ability to block certain jobs, right? So if you need some human interaction within your pipelines, you want to build an approval type job, right? And that's easily defined in your code. Let's go ahead and collapse this. And that's easily defined here in your workflow, right? So we created this workflow, and we created a what we call a dependency, so that, you know, when jobs are created or completed, you're able to say you cannot progress until these required things or the required jobs have been completed successfully. As you can see, we're deploying, we are deployed, AWS ECS deployed successfully. We now have the ability to proceed, right? So the approval button has reached that point. Now, once we click that button, it's going to go ahead and kick off this destroy AWS ECS job, right? Which will then destroy all of that infrastructure we created, all the EC2 clusters, all the Graviton2 compute nodes that are associated with that cluster. They'll be all destroyed and terminated as if they never existed. So let's go ahead and demonstrate that. I'm going to click the approve button. And once that button is approved, our AWS infrastructure will be destroyed, right? So once that happens, the cluster will be no more, and you will have a successful green build. As you can see, our destroy pipeline job has completed, which essentially again destroyed all of our resources created using Terraform in our previous build pipeline steps. So yeah, as you can see, and if you want to prove that doesn't work, let's go ahead and do a refresh on the site. Obviously, right, the site doesn't exist anymore. It just gets redirected over to Amazon.com. But again, right, the cluster is gone, or it should have been destroyed. If we look in our the EC2 instances have been terminated. And if we look at the ECS cluster, it should not exist anymore. So let's click on clusters. Obviously, I don't have any more clusters, right? So, you know, Terraform did its job. It destroyed everything. Again, I just want to leave you with, you know, again, this exciting release for our new features for ARM compute nodes. CircleCI makes it easy for you to start incorporating ARM development into your processes by giving you on-demand access to ARM compute nodes without, again, ever having to manage your own infrastructure for CI/CD. And with ARM gaining quick popularity, CircleCI is the best choice for engineers to, you know, build and future-proof their software. Thank you.